Welcome to the Explainer. Okay, so picture this. Your body's own security team, your immune system, suddenly goes rogue, and it starts targeting your most vital oxygen carriers, your red blood cells. Today, we are diving deep into this internal conflict, a battle that plays out in two very different arenas, one warm and one cold. This is autoimmune hemolytic anemia.
Right. This is the central question behind autoimmune hemolytic anemia, or AIHA. It's where this idea of protectors becoming attackers is a daily clinical reality. And, really getting a grip on the who, why, and how of this attack is absolutely critical, especially when you're staring down a question on exam day.
So here's our game plan for today. We're going to identify our two main culprits, we'll break down their different methods of attack, we'll figure out how to unmask them in the lab, and then finally, we'll look at the totally different strategies we need to use to shut them down. Let's get started. At its heart, autoimmune hemolysis is really a story of two different types of rogue antibodies. And the key distinction, the one that absolutely everything else hinges on, is temperature. You've got one antibody that likes it warm, regular body temperature, while the other one only really gets aggressive in the colds. So let's meet our two antagonists. On one side, you've got warm AIH. This is driven by IgG antibodies. Think of these as heat seekers. They are most destructive right at our core body temp. Then on the other side, we have cold agglutinin disease. This is the work of IgM antibodies, and they only go on the attack when the temperature drops, like in your fingers and toes. Just lock this in your brain right now. Warm equals IgG, cold equals IgM. All right, first up, let's track down that warm IgG antibody. Now, this is the more common of the two, and its method of destruction is, well, it's pretty specific and almost elegant in a really destructive way. So in warm IHI, these IgG antibodies basically act like little molecular flags. They go around tagging red blood cells, marking them for destruction. And the body's cleanup crew, specifically macrophages, in the spleen, they recognize these flags and just eliminate the cells. This all happens outside the blood vessels, so we call it extravascular hemolysis, with the spleen being ground zero for all the action. Now, here's where it gets really interesting. That splenic macrophage, it has these special receptors that grab onto that IgG flag. But it doesn't just swallow the cell whole. Oh no. Instead, it often just takes a bite out of the red blood cell's membrane. When that happens, the cell loses surface area, and it's forced into this small, dense little sphere. And that's our buzzword, a spherocyte. These spherocytes are super rigid, they can't squeeze through the spleen's narrow passages, and they ultimately get trapped and destroyed. So what does this look like in a patient? Well, it's a rapid onset of anemia symptoms. They're tired, short of breath, and they have jaundice from all those red blood cells being broken down. And because the spleen is working overtime, it often gets bigger, which we call splenomegaly. Now, about half the time we don't know the cause. It's idiopathic. But you always have to be on the lookout for underlying culprits like lupus, CLL, or even certain drugs. Okay, let's switch gears and turn our attention to the cold IgM antibody. Its method of attack is completely different. We're talking about a different organ and a whole other set of molecular triggers. With cold agglutinin disease, the troublemaker is this big, bulky IgM antibody. Out in the colder parts of the body, your fingers, toes, nose, it latches onto red blood cells. But its real power comes from its ability to activate the complement system. You can think of complement as the immune system's demolition crew. This whole process tags the red blood cells for destruction, but this time it's happening primarily in the liver. The mechanism here is so key. As that blood circulates from your cold fingertips back to the warmer core of your body, the IgM antibody actually lets go. But it's too late. It has already left behind this irreversible eat me signal from the complement cascade. A little protein called C3b is now stuck to the red blood cell. This C3b tag is then spotted by macrophages in the liver, and they just clear that cell right out of circulation. So the clinical picture is totally tied to the cold. Patients show up with acrocyanosis, that's mottled, blue, or numb fingers and toes that get way worse in the winter or when they grab something out of the freezer. While it can just happen on its own, it has these classic associations with infections like mycoplasma pneumonia and infectious mono. And let me tell you, those are super high-yield facts for your exams. So we have these two totally different ways that red blood cells are being destroyed. How in the world do we tell them apart in the lab? This is where the high-yield buzzwords really come into play, and you absolutely have to know these for your tests.
Okay, this slide is everything. Seriously, on the peripheral blood smear for warm AIHA, you see those little bitten cells, the spherocytes. For cold disease, those big IgM antibodies make the red blood cells clump together in the test tube, which we call agglutination. But the definitive test, the one that tells the whole story, is the direct Coombs test. For warm AIHA, it's positive for IgG. For cold disease, remember, the IgM has already detached, so the test is positive for complement only. This distinction is so vital. So the direct Coombs test, you might also see it called the DAT, it is the absolute cornerstone of diagnosis. It asks a really simple but powerful question. What is physically stuck to the surface of the patient's red blood cells? Is it an IgG antibody, or is it just that leftover piece of complement? The answer directly points you to a diagnosis of either warm or cold autoimmune hemolysis. It's that simple. All right, now that we know how to tell them apart, let's talk about how to fix it. And it makes sense, right? Since the places and the ways the destruction happens are fundamentally different, our treatment strategies have to be totally different too. For warm AIHA, where the spleen is the problem, the first-line treatment is just to suppress the whole immune system with corticosteroids like prednisone. If that doesn't work, you can even consider taking out the spleen itself. But for cold agglutinin disease, the #1 first-line treatment is just behavioral, stay warm and avoid the cold. It's that simple. We do have medications like rituximab and even newer drugs that specifically block that complement system. And this slide right here highlights a critical, super high yield point. Giving steroids or taking out the spleen in a patient with cold agglutinin disease is completely pointless. And why is that? Because the destruction is happening in the liver and it's driven by complement. You can't solve a liver problem by removing the spleen. This is a classic exam trap, so you've got to be ready for it. Okay, let's put it all together. This is your ultimate cheat sheet. Warm disease, IgG antibody, destruction in the spleen, spherocytes on the smear, and IgG-positive Coombs test, and you treat it first with prednisone. Cold disease, IgM antibody, destruction in the liver, agglutination on the smear, a complement-only Coombs, and the #1 treatment is just avoiding the cold. Take a screenshot of this. Memorize it. Know it inside and out. You know, at the end of the day, telling these two conditions apart is way more than just an academic exercise. It's about connecting the dots, from the patient's story to the lab results, and finally to the right treatment plan. The clues are always there. Your job is just to know how to read them. Thanks for joining us on The Explainer.